Welcome to the NASA series Exploring the Moon, where we take a behind-the-scenes look at the preparations for humanity's return to the Moon.
Basically, you should think of a spacesuit as a human-shaped spacecraft.
So in a spacesuit, you have to protect for everything, the entire space environment.
There's a lot of really cool new technologies that we've been working on to be more exploration forward.
This is a great place to be. It's a great time to be here working at NASA. So
Yeah.
Looking forward to seeing the real suit as it gets ready to go to the moon.
I'm Stephanie Cipolla. Today we have the pleasure of speaking with Liana Rodrigues, the NASA Spacesuit Development Lead. Hi, Liana. It's really good to have you here today.
Hi, Stephanie. I'm really happy to join you today to talk about spacesuits.
So let's start with the basics of spacesuits. Why do astronauts wear them? Why are they important? How do they work?
Yeah, so basically, you should think of a spacesuit as a human-shaped spacecraft. So anytime we go out away from the Earth atmosphere, we lose all the natural protection that we get from being here on Earth. And you have a very different, very harsh environment. So you have space vehicles that everyone talks about, but in order for the astronauts to get closer to their environment and go outside of their spacecraft, they need a small spacecraft. And it needs to fit them well and be shaped like them so they can really operate as if they were just out there doing whatever they were meant to do.
Okay. And so in a spacesuit, you have to protect for everything, the entire space environment.
Exactly. So there's different functions that the spacesuit provides that make up basically the overall life support system. So it's an enclosure, so it maintains the pressure that you would normally have on Earth, except at a lower pressure.
Okay.
And then it has oxygen, because you have to be able to breathe, and it has carbon dioxide removal, which happens naturally here. You don't think about it, but
You're right. We have all this beautiful green scenery around us that
Exactly.
take care of that. You probably don't keep a tree inside the spacesuit.
Nope, that's not our technology of choice. But so it has those kind of capabilities. It also has thermal considerations, so keeping you the right temperature, not too hot, not too cold, and then you want to be able to fit in it and do work in it and be mobile. So Sure. Yeah. So that's really interesting because, not every human and probably not every astronaut is the same size. So how do you deal with different size humans and do we have a whole closet of spacesuits? What do we do about this? Yeah, that is a really, really challenging part of building this kind of enclosure for humans. It's trying to accommodate all the sizes, and really we want to. In the past, we didn't always have hardware that fit everybody, but that's definitely something we're doing going forward with advanced suits. The way you manage it is you do have a few sizes, but mostly in just a couple of the main parts of the suit.
Okay.
And then you might have more sizes of things that are like your gloves, because everybody's hands very different. Arms and legs can be adjusted, and that's how we get them to fit all the people that you need. So
does that mean that all of those spacesuits will have to be on the surface of the moon so that the astronauts can go to the closet and choose the right size or customize it? How do we do that for actual missions?
Yeah, so for actual missions, you know who your crew is beforehand, and you can do a lot of that sizing here on Earth and making sure you have a suit that was going to work really well for them. But the suit itself has a lot of adjustability. So once you get in space, especially in microgravity, the astronauts actually grow taller, and so you have to be able to adjust the suit to fit them when they're there.
Okay.
So for longer missions at the moon and farther away, we can't just fly up a spare part if something goes wrong. So we will have to have some additional spare parts of certain things for that.
Okay.
Yeah.
You bring up the space station. I was just thinking about that while you're talking. This isn't a new problem. Right? Astronauts that go to the space station are different sizes. Astronauts that will go to the moon are going to be different sizes. So are we doing anything differently for the lunar spacesuits than what we've been doing for space station?
Yeah, we definitely have learned a lot from our past experience with spacesuits and how they fit people. So there are some new features in this suit right now, and there's a prototype here on display behind us.
Yes, it's fabulous.
This is a prototype spacesuit that NASA has developed in-house to advance the different technologies. And one of the things that you can sort of see on it is the arms on this suit are very far in, sort of close to your neck, as a shoulder joint. And the shoulder joint on the EMU, the current spacesuit, is way out here at the end of your shoulders. And you don't think about that too much, but when you try to move your arms around or do anything, your whole shoulder moves. And so bringing that joint in closer here is allowing for much more range of motion, for more natural, and it also improves the fit. So you can adjust that position by several inches based on who's going to be wearing the suit.
Okay. I can imagine how that helps a lot, because if you're going to do work, you're likely going to use both hands. And if you do that, your shoulders come forward, your arms go forward. And I can see how the smaller distance between the shoulder rings would help the astronauts do that work.
Yes, definitely.
I'm sure they would appreciate that. So I saw that you brought some material with you.
Yeah, I did. I wanted to show you some of the types of textiles that go into developing a spacesuit.
Okay.
So this is the layup of multiple materials that make the outer part of the suit.
Okay.
So if you look at the prototype we brought and all the suits you see in any kind of footage of spacewalks, it's white.
They're always white.
They're always white.
Right, okay.
And sometimes you'll see some other colors when you see ground testing of suits. And that's fine, because we don't need it to perform the function that it does in space, and so you can be a little more creative with colors on the ground.
Sure.
But in space it's going to be white.
Okay.
The white provides thermal protection, so it basically reflects the light and helps keep temperature control. And this top layer also has other functions, so you can kind of see grid pattern on the back.
Right.
This is a very tough material, and it is used to protect from impacts of tiny space dust and any kind of micrometeoroid that might
Very
impact
important.
a crew. Yep.
Holes in a spacesuit would be a bad day.
Definitely a bad day. So,
Yeah.
although I'll talk about that, but let me tell you about the layers.
Yeah, tell me
first.
about the layers. Okay,
Yeah.
you have lots of the next one, and they're shiny.
Yeah, so these are shiny. These are aluminized mylar.
Okay.
So it's basically there for thermal protection.
Okay.
So they have several different layers together. They work as a unit to help control the temperature.
Okay. And it looks really similar to the blankets you see, at the sporting goods store that you can buy for camping. Is it the same?
It is. So
material?
those are space blankets, is what I've
nice.
heard. I've heard them called that anyway. And,
Nice.
and yeah, it's a very similar thing. It will trap heat.
Okay.
And then the inside layer just sort of makes up the final step of this. It's also has a characteristic about it that prevents for holes to spread too much or anything like that.
Oh,
so
sure.
the whole thing is just what we call the environmental protection garment. that's
Yeah, it does
outside.
a whole lot more than just look good.
Exactly.
Right. Okay,
Yeah.
that's neat. Thank you for sharing that.
Recently, my colleague Carly McGinnis had the opportunity to speak with astronaut Sunita Williams about her experiences spacewalking in the current spacesuit called the EMU, and also about what differences there will be between that spacesuit and the one that we are in development now for lunar missions.
Hi, my name's Carly McGinnis. I'm the lead for the Advanced Spacesuit Portable Life Support System, or PLIS, development here at NASA at the Johnson Space Center. And today I'm in the Spacesuit Pressure Garment Subsystem Lab, and I'm thrilled to be joined by astronaut Sunny Williams to talk about our advanced spacesuits. So I recently learned that you were in one of our advanced suit prototypes in the Argos facility, which is a reduced gravity simulation environment. Can you tell me about that test and what your experience was?
Sure. This is a great place to be. It's a great time to be here working at NASA. But actually, I'm going to be flying on a Boeing Starliner as part of the commercial crew program. I was in one of these advanced suits in the reduced gravity facility, like you mentioned, practicing getting out of a simulated lunar lander, actually hooking up some electrical connectors or some hydraulic connectors, and then actually taking sandbags and moving them across a simulated lunar surface, just to see how we perform before we go to space. And then when we return from space later this year, we'll do it all over again to see how the body changes in space and what the effects are, and if you can do the same tasks. But I tell you what, having done a couple of spacewalks in space in a different suit called the EMU, the Extravehicular Mobility Unit, which is designed to operate in microgravity, not necessarily planetary, this suit is awesome. I love this suit. I love everything about it. The workload in any of these suits is pretty high. However, the advancements that we've made over the years make it a lot easier for many, many reasons. We could talk about that if you'd like to.
Yeah, I would love to, because I've been working on this suit for almost 12 years, and my heart and soul has gone into those technological advancements, so I'd love to hear why it's so much better, because I certainly think it is.
Yeah. So one of the things that I think is really great about the suit is your field of view. In the suit that we use for spacewalks on the International Space Station, you only have so far that you can see, and so you actually have to move your whole body to be able to look to your left or to your right to plan where you're going to go. In this one, you can just sort of lean forward and look up to the right, look to the left, because the visor comes out a little bit away from your head, and so that way you don't have to use that energy. Also, the joints in the suit allow you lots of mobility, a lot more mobility for you to actually raise your hand above your head, and your hips allows you to actually do a knee bend or a squat, get your knee on the ground to maybe pick up something on a planetary surface. So it's really mobile and allows you to do a lot more things than we have in our heritage suit.
Yeah, and as I'm sure you're aware, some of those mobility improvements are because this is a rear entry suit where the hatch swings open on the back and you climb in and don and doff the suit from the back, as opposed to the current suit which breaks at the waist and you have to wiggle up through the upper torso. So that's one of the improvements that helps us move the arm bearings in and get better range of motion.
And I love it also because that way you can don the suit yourself and you can take it off yourself, versus the suit that we had, the heritage suit, you need other people to help you really get into the suit. This one, I think the idea would be maybe hang it on the back of a rover, right? And so then you could get in it from inside the rover, close the door, and then off you go. So I think it's a great idea. The rear entry is really convenient.
Wonderful. So you are a veteran spacewalking crew member on ISS. What are some of the differences that would be expected between a microgravity spacewalk versus a planetary, such as a lunar spacewalk?
Yeah, we call it a spacewalk on the International Space Station and on the shuttle in that time frame, but we're not really walking. We're actually operating on a ISS, an International Space Station, or some type of satellite that has handrails, and you're actually doing hand over hand over hand to move. And so the legs actually don't have to be supportive. You don't need to stand up. You do have a backpack, like you mentioned, that you work on, which has all of the heating and cooling and oxygen, carbon dioxide removal, so it's the same there. But the tasks are really for maintenance tasks or construction tasks in the beginning of the International Space Station. So they're primarily tool heavy here and hand operating to do those tasks. Where the planetary suit, you probably have some tools on you, but you have the ability to actually bring tools with you if you had a rover, and you don't have to carry all of them. And that's convenient because of the things like I was mentioning. If we are going to do some construction on a planetary surface, you want to have your hands free, your area free, the ability to bend down, to dig, to grab, to do something like that. And so this suit lends itself to being able to do that. And the legs actually have to support you, even though it's reduced gravity, on the moon. We still have to be supported, and that's obviously a difference from the space station spacewalks.
Absolutely. And you mentioned the backpack, so I'll tell you, you may know this already, but there's a lot of really cool new technologies. For long-term exploration missions, we're looking at reducing consumables and making the suit more suited for in-field maintenance. So
I love that.
Yeah. So one of the key technologies that we have been working on is a regenerative system that you mentioned, removes carbon dioxide from the suit, and it would completely eliminate a consumable that's in the current suit. So that's really cool and something that we're looking forward to going forward when we go back to the moon.
Absolutely, because these suits are going to take a beating, right? So the moon environment is very rigorous, and we're probably going to have some things that are going to need repairs. And so that type of technology advancements are going to make it so easy. We're not going to have the luxury that we've had in the shuttle days and somewhat here on the commercial crew days where we send a suit back home. We're going to want to have the suits there and have the crew members, the astronauts there, be able to do all that maintenance. So that's awesome. That's really good to hear.
Yeah, and you mentioned that it's a rugged environment on the moon, and that the suit is going to take a beating. The suits do get a lot of wear and tear on ISS, and the lunar surface is so much more aggressive. I mean, such a harsh radiation environment. Lunar regolith is, we always say it's like tiny little shards of glass that have so much electrostatic charge. They cling to everything. It's very abrasive. So there's a lot of materials development work that's ongoing to try to make it more robust in that environment.
That's awesome. I think we're capitalizing on the lessons we learned from Apollo when we went to the moon, and then ISS as we use these types of spacesuits time and time again, and it's culminating in a really good suit. So looking forward to seeing the real suit as it gets ready to go to the moon.
In addition to Argos, the reduced gravity test facility, there's a lot of other analog facilities like the neutral buoyancy lab, and we've done testing in the Arizona deserts and other desert locations in the U.S. and even recently in Iceland. From the crew perspective, can you tell us, how are these analogs used for training, and how does that help prepare you for spacewalks?
Yeah, I'll quickly start with the NBL, and I have seen the planetary surface in the bottom of the pool, and I have actually just been training for a space station. So I've done in the other suit, the older suit, the heritage suit. I've been climbing around on the space station, looking down there, and say, hey, that looks pretty fun down there. But I know my suit isn't one that would be able to stand up. I have been in early version, trying it out and trying to just see how much mobility you have, and if we could actually adapt it to the space station to get a microgravity test on it. It's great because we have a thing, a foot plate. It allows you to stand still while you're working to let your hands be free. And when we're getting in the heritage suit, you have to turn your whole hip to get your foot into this foot plate. You stick your toe in, and then you have to really move your whole leg like this to get in. And in this new suit, you just put your toe in, and you can just turn your ankle like you can naturally turn your ankle, and you're snapped up right in immediately. And it was so convenient. You can also, in the new suit, in that foot restraint, you can lean practically all the way over. You can bend your knees. You can move yourself all sorts of ways, which the heritage suit could not. So the MBL gives us an environment of neutral buoyancy. As we work here in Argos, one of the things that was obvious to me is I felt my body was the load alleviated, but my arms still weighed a lot. So in the neutral buoyancy lab, everything is equally unweighted, and so it allows you to extrapolate a little bit more, a little bit closer to how the suit is going to work. And then when we go to these other analog areas, it gives you the real terrain. In water, we do a little negative training because it's a little bit hard to get going in this big, massive suit, that momentum, and it's really easy to stop. Versus if you are in air or microgravity or space, whatever, it's super easy to move that momentum, but then it's hard to stop. So it's a little bit opposite training. You have to keep that in mind. So these different types of analogs and the NBL and Argos here, that allows us to put the whole picture together and really be ready for what we're gonna face when we get to the moon.
That's so interesting, putting together the pieces of all the different analog experiences and putting them to try to in totality simulate the spacewalking experience, because you can't do it in any one training facility.
Unfortunately, we don't have a space room.
Or an anti-gravity chamber. We've been working on it, but it's just not coming together. The suit is a pressure vessel, so it's inflated like a balloon, and that, if you think of a basketball that's inflated, it's hard. And so the suit is hard. The soft suit is hard when it's pressurized, and you actually have to work against the suit materials to articulate your limbs. And that's true of the current suit and the advanced suits. So, can you talk about that a little bit?
Sure.
How does that make your job more difficult?
Yeah. I mean, I'll just start right from the hands, right? So your gloves, it's like, you're wearing a snow gloves and you're trying to do some meticulous work when you're doing things with your hands. And not only that, those snow gloves are like hard, like you mentioned. And so when you're putting your fingers, using your fingers, they're going to be hitting that end of it. And every spacewalk I've come out of, my hands are just like really tired because your ends are getting hit like pretty hard, and then you're also trying to grip things. Obviously, the way we use our hands is gripping, right? You're trying to grip a tether or a piece of equipment or a handrail. Same will be true in the lunar suit. We're going to be holding tools or driving maybe or something, right? So you want to have gloves that fit you really well so that hand fatigue is not as bad and that wear and tear on your hands is not as bad. These suits right now have the same gloves, so that is still going to be a factor. One of the cool things about this suit, and a little bit different again from the Heritage suit, has bearing which are a little bit wider on the shoulders, and it makes it a little bit hard to like bring your arm over to your work site or move your arm up. You're sort of like having to figure out how to move it. These, with the bearings a little bit closer in, you can actually use your arm like your normal shoulder would be, so you can come across your body. You can come up around your head, to close your sunshade or to reach something that might be overhead. So it's really a lot better. And things I mentioned real quickly about the legs and also the hips, the increased joints in the hips and legs, which provide the support which we'll need on a planetary surface, also allow you to swivel. So one of the real great advantages I mentioned about the field of view from the helmet is enhanced even more so by the hips, because you can swivel versus trying to take your whole body and move your body like around, turn your body pivoted. When I'm talking to some of the newer astronauts, part of the thing that they ask when they get in the suit is like, how do I move? This is so weird. I'm in this big balloon. I don't know really how to maneuver myself around. I'm like, you have to just get used to operating your body a little different way than it normally does. Work with those joints. Don't fight against it, because you will lose in that pressurized suit. In this suit, it's actually a lot closer to the way your body works, and so I think some of those lessons might be bad lessons learned as we get into the new suit, because take advantage of how your body actually moves.
Right.
It's great.
Yeah, that's
it's really,
great.
Really good.
That's what we're trying to achieve. So can you talk for a minute about what you think? Why do we have a spacesuit? Why do we send people to these places? NASA also does a lot of unmanned rover exploration, but we also develop spacesuits, and so why do we do this?
Yeah, the spacesuit, it is, the highlight, the pinnacle of actually going to space. It is its own spacecraft, like you've mentioned already about the things that are in it, how its components. It keeps you alive. It allows you to do work. It allows that person to be hands and eyes and feet on the scene doing the activity. We can program robots, and we've done it so well. And with advanced technologies, we've been able to put algorithms in there so they can do neat things, but they're all subject to what somebody potentially thought beforehand and incorporated. The human in the suit doing the activity can make that decision. Mm-hmm. Do I go right? Do I go left? Do I pick this up? Is it worth it? Do I spend time here, or do I go over here? To really enhance the science that we're going to do when we get back to the moon. And the spacesuit obviously is what allows us to do that. Yeah. So making it comfortable, making it work easy, and all that kind of stuff, as well as protect us for, the extreme temperatures, the radiation, the lighting, meteorites on a ISS spacewalk. Suit is really key.
All right, Sunny, thank you so much for coming out this afternoon and talking to me about your experiences as a spacewalking crew member. Yeah, and thank you so much for your work developing our advanced suit technologies.
I love it.
Yeah.
Will you walk us through, you said that this spacesuit, even in pieces of technologies, that this spacesuit has been in development for over 10 years.
Yes.
Talk us through a development process or the development cycle of a spacesuit.
Sure. So we basically, again, starting with what is that you need the suit to do, and then break it down into those areas, and then talk about how can you fulfill that need. So from the life support perspective, that work started also probably 15 years ago, and we were looking at what's a better way to do some of the capabilities we have. For example, carbon dioxide removal. So some of the current technologies that we use, or actually going back a little further, originally we used canisters that would absorb carbon dioxide. They're located in the backpack in the Bliss, and those had to be removed and replaced.
For every spacewalk?
For every spacewalk.
Okay.
And so if you imagine being far from home, that's not very practical to have that kind of logistics needed to do that.
Right.
That suit advanced to a canister that is regenerable by baking it.
Okay.
So it still requires you to have an oven, and the component requires sort of maintenance cycle and all of that. So
And you're still taking it in and out after every EVA.
Exactly. So we're looking for something a little bit more robust and less hands-on, less time required with it. And that's where the new technology comes in. It's called rapid cycle amine, and it's basically a canister that has 2 different beds of this absorbent material that loves carbon dioxide, also loves water. And so the spacesuit ventilation loop that the crew is breathing from will have 1 bed exposed in there, and as they expel carbon dioxide and water vapor, it gets absorbed into that bed. And when that bed gets full, there's a valve that swings to the next bed, and this bed is exposed to the vacuum of space. And this type of material in here, the amine, will basically release all of that into the vacuum of space and get totally
So
cleaned
that's
out.
fascinating, because then you don't need this oven that we're using today. You're recycling, reducing, reusing, being kind to the environment and kind to our upmass requirements, right? Because if you had to fly an oven to the moon, I can only imagine how much that would weigh and how much power it would take, and all of those
mass,
things.
power, logistics, everything is improved by this sorts of technologies. So that's how we advance. That's how we.
And that's
talk
just
about
one
it.
piece. That's just your carbon dioxide read.
Exactly.
Okay, so what about all the other pieces?
So similar developments happen on other key technologies, including cooling. So the technology we've been working on for the advanced spacesuit is called the water membrane evaporator, and it's basically a cartridge or set of cartridges that have thousands of tiny little fibers, and the water flows through those fibers and evaporates out, and through evaporation cools the water that's left in there, which circles through the suit. And the water is on the suit not to drink. That's a different feature. This water is there, again, for cooling both the person and the equipment that generates.
Your own personal air conditioning.
Your own personal air conditioning. So the spacesuit, the spacesuit has an under layer called the liquid cooling and ventilation garment. It's like long johns, and it has just very many feet of tubing sewn through the fabric, and it's worn up against the body, and that's how they suck the heat. You know, when you're working hard and you start to build up a little sweat, it can pull that heat out.
Sure, you have all those tubes of cool water running against your body.
Exactly.
Nice. Liana, thank you so much for joining us today. This has been a really interesting conversation. I've really enjoyed looking deeper into lunar spacesuit development.
Thank you so much for having me. It's been really fun to be able to share this with everyone.
And thank you for joining us in today's episode.